Let's take a look at simplifying rational expressions. I have a few problems here. So here we have a polynomial divided by another polynomial, and we need to factor the denominator. This one factors pretty easily since we have simple numbers there. 2 is 2 times 1, and 1 plus 2 is 3, so this should be y plus 1 times y plus 2. Coincidentally, we've got a y plus 1 in the numerator, and a number divided by itself is 1. And that's why we say these cancel, because we have a division here and a multiplication there. Now the catch is the simplification of a number divided by itself is 1. So this expression has a numerator now of 1 and a denominator now of y plus 2. So our claim here is that no matter what number we plug in for y, this expression here will give us the same answers as this expression here. Now there is one small catch. We eliminated the y plus 1s here, and so that is a slight complication, which I'm not going to worry about right now. So the only way to really check to see that this is right is pick some number for y and plug it into the original and plug it into the ending value and hope they match. I'm going to do that just for fun. So I believe this is the answer, simplified expression, and I'm going to check by picking a convenient number, and let's say I'm going to plug in y equals 2. So plugging that into the numerator, I get 2 plus 1. The denominator, I'm going to get 2 squared plus 3 times 2 plus 2. So that gives me 3 over 12, which reduces down to 1/4. When I plug y equals 2 into this one right here, I get 1 divided by 2 plus 2, and so I get the same value. So this is called check by evaluation. Now it could be we just got lucky that it works for 2 and nothing else. So you could try checking another number. Alternatively, you could graph this as a function, and you could graph that as a function and see if the functions line up in something like Desmos. Let's try another one. So here I have to multiply and simplify. So I have a rational expression times another rational expression. And you might say, hey, can I simplify by taking x divided by x is 1? And the answer is no, you can't. There's an implicit parentheses around the numerator and the denominator. Because this fraction bar is big, means you have to simplify the numerator and the denominator before you can act on division. And as we saw over here, canceling is doing division. It's saying a number divided by itself is 1. So we can't do the division until we can simplify x minus 1, and we can't simplify x minus 1 because we don't know what it is. What we can do, however, is factor this numerator and see if there's any common factors top and bottom. So 8 factors as 1 times 8 or 2 times 4. And if I take 2 minus 4, I get -2, which is the middle coefficient. So that means the 2 and the 4 are involved in my factoring. 2 is positive, 4 is negative. So this must be in the numerator, x plus 2 times x minus 4. Now, when you multiply fractions, you just multiply the numerators together. That means I'm going to have an x minus 1 in the top multiplied. I have these 3 factors multiplied in the top. In the bottom, I'm going to have just the x minus 5 factor and times x plus 2. Here, here I have a common factor again. So the x minus 2 here is common to the x minus 2, and a number divided by itself is 1. Multiplying by 1 is kind of boring here, so that means this must simplify as x minus 4 in the top times x minus 1 all over x minus 5. So I've multiplied and simplified. Something canceled. Things don't always cancel. There's no point in multiplying these together and calling it x squared, blah, blah, blah. The factored form here shows me clearly nothing else cancels. So I would leave this like this. This is my final simplified answer. If you wish to check, you could pick a number, maybe x equals 2, plug it into the original, do the arithmetic, plug it in here, do the arithmetic, and pray they match. If they do, chances are this is an equivalent version, because we're claiming these two are equal no matter what value of x we pick. All right, here I have to add, simplify, and reduce if necessary. So to add fractions, you have to have a common denominator. These denominators are different. Our standard process for adding is to find a lowest common denominator, which means we have to have each denominator in factored form. So x is pretty simple, but x squared plus 4x, that factors. So I am going to rewrite that just underneath here as x times x plus 4. Cross that out. So this is my new denominator. I can see they have in common an x, but the first fraction is missing the x plus 4. So that means I have to multiply that in to get a common denominator. So I'm going to take that 3 over x, and I'm going to multiply top and bottom by x plus 4. Then that'll give me a common denominator, so I can add that fraction to the fraction 6 over x times x plus 4. Adding fractions, you keep the common denominator and add the numerators. So that's going to give me a 3 times x plus 4 is one of the numerators, and 6 is the other numerator. Now, I need to simplify this. So to do that, I'll have to distribute the 3 through. It's going to give me 3x plus 12 plus 6 in the top. And then we have some common like terms there. 12 and 6 is 18, so that's 3x plus 18 in the top. For x times x plus 4. And 3x plus 18, that factors, right? We can pull a 3 out of that. And I'm factoring it to see if anything cancels. So 3 times x plus 6. Nope, nothing cancels. Oops. So I would say this is the final answer, because the factored form shows me nothing is common in the top and the bottom. This would be adequate too, but I wouldn't circle more than one thing just in case there's a mistake. So I'm going to go with that one right there. That's my final reduced form. The only way to check for sure that this equals that is to pick some number for x, plug it in, and see if they're equal. So I'm going to do that for here just for fun. I'm going to do again what's called check by evaluating. And I'm going to pick x equals 0 or 1 are kind of dangerous in some problems. I'm going to go for this time. And negative numbers are a pain because we often pick sign errors. So in the original, that's going to give me 3 over 3 plus 6 over, and I'm going to go with the original version, not my altered version. So that's going to give me a 3 squared, which is a 9. Plus 4 times 3, which would be 12. And what does that give me? 1 plus 6 over 21 is 1. Let's see, 6 over 21 reduces because 3 goes into 6 and 21. So 1 and 2/7. Call that good enough. Check this one over here, and we get 3 times 3 plus 6 is 9. Over in the bottom, we'll get 3 times 3 plus 4 is 7. The 3's divide out because I have a number divided by itself, which leaves 9/7. So the question is 9/7 the same as 1 2/7? Two ways to check that. One, you could combine those. One would be 7/7 plus 2/7. Yep, that's 9/7. So I found that if x equals 3, then the original expression is equal to my reduced and added expression. So I feel pretty good about my answer. I found a way to check. I have a reduced answer. Another. This is a complex rational expression because I have fractions within fractions. So there's two ways to deal with this. One way is to identify the common denominator of both the top and the bottom at once. So the lowest common denominator approach. The denominator of the numerator is x. The denominator of the denominator is 5. Multiplying those two together, I get 5x. It's the lowest common denominator. Then what we do is we multiply that LCD by the top and the bottom. So that means I take my original 2 plus 4 over x, and I multiply it by 5x. Same thing in the bottom. Take my x plus 1 over 5 and multiply it by 5x. And this is legal because I'm multiplying top and bottom by the same thing. And essentially that means I have a number divided by itself, right, which is a factor of 1. But we're going to not cancel that 5x over 5x. We're going to distribute it through top and bottom. So 5x times 2 is 10x. And then I have 4 over x, times 5x, which I give you as 5x over 1. And here I have x's common to top and bottom of this fraction. And so they cancel out. Those become 1s. So that means the numerator did simplify a little bit. It's now just, let's see, what do I have? 10x plus 4 times 5 is 20 over 1. Dividing by 1 is kind of boring, so I can just say that's 10x plus 20 in the numerator. Do the same thing down here, multiply by 5x. 5x times x, 5x squared. And I'm going to have a 1/5 times 5x, which I can do as 5x over 1. And this time it's the 5's that are common top and bottom, this new fraction. And so those 5 divided by 5 is 1. So what's left? 1 times x, which is an x, and 1's in the bottom, right? So the whole point of the LCD at the top and bottom is it eliminates the denominators that are in each numerator and denominator of the complex fraction. So now I have a regular rational expression, which is 5x squared plus x in the bottom. Next, I need to see if this reduces any further. So then I look at the numerator and say, does that factor? Yes, it does. I can factor out a 10, which leaves x plus 2. And here I can factor out an x, which leaves 5x plus 1. And I can see that 10 as a factor is not common to the bottom, x as a factor is not common to the top, x plus 2 is not in the bottom, and 5x plus 1 is not in the top. So this definitely is the reduced version. Since nothing canceled, I could also circle that red expression as my answer too. I'm going to go with the factored form because I can clearly see there's no common factors. So I have simplified the complex rational expression. I'm just going to do that again a different way. So the LCD method is quite nice. We just identify the LCD of the top and the bottom together, multiply the top and bottom by that, which should cancel extra denominator stuff, giving you a regular rational expression instead of one with fractions within fractions. So alternate approach is kind of following the order of operations. So let's do that one more time a slightly different way. What I'm going to do this time is just note that, hey, there's this big fraction bar here. that means divide. And before I can divide, I have to clean up the top, which means I need to perform this addition right there. Okay? So to take 2 and add it to 4 over x, I need a common denominator. So 2 plus 4 over x. Common denominator, if I view that as 2 over 1, would be x. That means I have to multiply an x into the top and the bottom there. Do that again, different color. Getting a common denominator. So now my denominator in the numerator is x, so I have that common denominator. My numerator is now 2x plus 4. Okay. All right, so then I do the same thing for the denominator. I take my x plus 1 over 5 and I act on that addition by finding a common denominator just for the bottom. So I'll view that as x over 1, 1 over 5. 5 is the denominator I want, so I'm going to multiply this by 5, top and bottom, and see what I get. So fraction bar matching this one, which matches that one. X times 5, I could just call 5x plus 1 over 5. So you may say, well, that looks worse. However, the next trick is to note that if you take a fraction and divide by another fraction, division of fractions is multiplying by the reciprocal. So I'm going to change this division here to multiplying by the reciprocal. That means I take this guy here, 2x plus 4 over x, and I multiply it by the reciprocal of the denominator, and that would be 5 over 5x plus 1. Multiplying fractions, you just multiply the numerator, multiply the denominator. Now before I multiply, I'm just going to note here, nothing cancels. My numerators are totally different than my denominators. So multiplying 5 times 2x plus 4 gives me 10x plus 20. And x times 5x plus 1 gives me 5x squared plus x. And that sucker right there matches this sucker right here. So a slightly different approach. They're both good. Just depends on your upbringing which one you like better. So I would recommend practicing both and making a decision on whether you like the LCD method or just clean up the top and bottom following the order of operations. Have a good day. Do good math.